Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 7.3, factoring x squared plus bx plus c. So when you're factoring trinomials, you know how to multiply binomials. For example, if you're multiplying these out, you're going to FOIL them, right? X times negative 5, 3 times x, and 3 times negative 5, and you get x squared minus 2x minus 15. So we're going to be doing the reverse of this. We're going to be taking something that's a trinomial and we're going to put it into its factors, okay? So let's just do this one off to the side. All right, so if I have x plus 3 times x minus 5. This is the answer that I want to get to. So let's look at what we have. We have this once it's FOILed out. So what I do is I do all the factors of negative 15. So I have 1 and 15, 3 and 5. Right? Like 1, 2 doesn't work, 3 works, 4 doesn't work, back to 5, so we know that we have all the factors. What multiplies to negative 15 and adds to negative 2? So it adds to negative 2 and multiplies to negative 15. So what multiplies to negative 15 and adds to negative 2? How about negative 5 and positive 3? Right? Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. So now I just go x plus 3 times x minus 5, and those are my factors. When they're asking for your solutions, use the zero product property. And the zero product property just says to set these factors equal to 0 and solve. So x equals negative 3. And x equals 5. So negative 3 and 5 are your solutions, right? So you factor it to get your solutions. What are your solutions? Your solutions are your x-intercepts, right? Solutions, x-intercepts, zeros, roots. These all are synonyms. Your solutions, your x-intercepts, your zeros, your roots. They'll say, what is the root of? What are the zeros? What are the x-intercepts? What are the solutions? And they all mean the same thing. So basically all this is saying is that this parabola crosses at negative 3 and 5. The parabola is going to cross. This is a like it's not negative, it's positive, so we know that the parabola goes up. Okay? And then what we're going to learn later on, we'll learn how to find the vertex, where to plot it, and how to graph the whole equation. We're just not getting into all that just yet. We're just doing the factoring portion of this lesson. Okay? So we know these two are the x-intercepts. We know that our equation is going to look like this. It's going to be a parabola. We're not sure where these points are. You know, we don't know where the vertex is and all that stuff yet because we didn't actually solve for it, and we're not going to get that far. We're really just stopping right here at factoring, but I just kind of wanted to foreshadow where we are heading. Okay, this is where we're going to be heading with it, but right now you're just factoring. So if I wanted to factor this, I'm going to have 1 and 8. What else goes into 8? 2 times 4. Does 3 work? No, we're back to 4. So those are all the factors of 8. What multiplies to 8 and adds to negative 6? How about negative 4 and negative 2? Negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. So x minus 2 times x minus 4 are the factors of x squared minus 6x plus 8. If they asked us for the solutions, which we're not really into yet, you would do the zero product property, set these equal to 0 and solve, and you get solutions of 2 and 4, which means that it crosses the x-axis. Your x-intercepts are at 2 and 4. You want to factor this, okay? So x squared minus 2x minus 15 versus x squared plus 2x minus 15. 1 and 15. Does 2 go into 15? No. 3. 3 times 5. 4. No. We're back up to 5, so these are all the factors. What multiplies to negative 15 and adds to negative 2? Anybody? Multiplies to negative 15 and adds to negative 2. How about negative 5 and positive 3? Look, x squared plus 3x minus 5x is negative 2x minus 15. It FOILs out to this. Over here, what multiplies to negative 15 and adds to positive 2? How about positive 5 and negative 3? X minus 3, x plus 5. So on this one, let's look. X squared plus 5x minus 3x, those add to positive 2x minus 15. Okay, so these actually have the opposite signs. Use factoring patterns to factor this and this. What do you notice about the factored forms? What special type of trinomials are these? Okay, so 16. 1 and 16, 2 and 8. Does 3 go into 16? No. 4 times 4. And we're done. So what multiplies to 16 and adds to 8? How about 4 and 4? X plus 4 times x plus 4. Let's look at this one. 1 and 9. 2 doesn't work. 3 times 3. We're done. We have all the factors. What multiplies to 9 and adds to negative 6? Negative 3 and negative 3. X minus 3 times x minus 3. So these are both repeated, right? These are, the binomials are squared. Factor this. X squared plus 3x minus 10. Try this on your own. One times 10, 2 times 5, 3 doesn't work, 4 doesn't work. We're back to 5, so we know these are the only factors. What multiplies to negative 10 and adds to 3? How about positive 5, negative 2? They add to positive 3 and they multiply to negative 10. So you have x minus 2 times x plus 5. Alright, so on the next one, x squared minus 8x minus 48. 1 times 48. 2 times what? 24, right? Does 3 go into 48? 3 times 16. 4 times 12. 5, no. 6. 6 times 8. 7, no. Back to 8, so we know these are all the factors of 48. What multiplies to negative 48, so it's either a negative times a positive, right? To get a negative times a positive, and adds to negative 8. How about negative 12 and positive 4? Negative 12 plus 4 is negative 8. Negative 12 times 4 is negative 48. So it's x plus 4, x minus 12. And we can quickly, x squared minus 12x plus 4x, that gives us a negative 8x minus 48. So we know we're good. This is the only work I expect from you guys. Complete the table below. Assume that B, C, P, and Q are positive numbers. Okay, so if you're factoring this, to get a positive, it's a positive times a positive or a negative times a negative, and if they add to a positive, it must have been a positive times a positive. For a positive, it's either a positive times a positive or a negative times a negative. For the middle term to be negative, it needed to have been a negative times a negative. And then for here, for it to be negative, you had to have a positive and a negative. All right, so let's get on to this practice. So for 5, 1 and 5. 2 doesn't work, 3 doesn't work, 4 doesn't work. Those are the only factors. So positive 1 and positive 5, add to positive 6 and multiply to 5. Try number 2. This one is actually a special one. This is called difference of squares. So difference of squares, you have a perfect square minus a perfect square. Your answer is going to be the square root of this plus and minus the square root of that. Because you get z squared minus 11z plus 11z, your middle terms cancel out, minus 121. So when you have a perfect square minus a perfect square, your answer is take the square root of both of them and do the plus and minus versions. Try number 3, because number 3 is like we've been doing. So I got 1 and 24, 2 and 12, 3 and 8, 4 and 6. What multiplies to negative 24 and adds to positive 5? So 8 minus 3 is 5. 8 times negative 3 is negative 24. So d plus 8, d minus 3 times d minus 3. This one's difference of squares. What is the square root of x to the 4th? It would be x squared, right? Square root of 4 is 2, so it's plus and minus 2. Factors of 4. 1 and, everybody. 1 and 4, 2 and those already are next to each other, so there's no more numbers. All right, so 1 and 4, 2 and 2. What multiplies to negative 4 and adds to positive 3? So positive 4, negative 1. So this is y minus 1, y plus 4. And you can quickly think about it in your head. Y squared plus 4y minus 1y is y squared plus 3y, right? Minus 4. You can quickly FOIL it out and think about what's going on. Try number 6. You guys get x minus 1 times x minus 1. Another way you can write this is x minus 1 squared. Your only factors were 1 times 1, and negative 1 plus negative 1 is negative 2. Number 7. List all your factors first. 1 and 24, 2 and 12, 3 and 8, 4 and 6. What multiplies to negative 24 and adds to negative 2? Jean. So negative 6 and positive 4. P plus 4 times P minus 6. P squared minus 6P plus 4P is in the minus 2P, minus 24. So we're good. Try number 8. Difference of squares, right? Perfect square minus perfect square. You take the square root of both of them, and you do the plus and minus version. Try 9. Anyone brave enough to tell me the factors? Three and 4. Negative 3 and negative 4 multiplied to positive 12, and negative 3 plus negative 4 is negative 7. Next one. 1 and 100, 2 and 50. Does 3 go into 100? No. 4 and 25, 5 and 20, 6, no. 7, no. 8, no. 9, no. 10 times 10. And that's all the factors. What multiplies to 100 and adds to 25? 5 and 20. Q plus 5. Q plus 20. And I always quickly go in my head. Q squared plus 20Q plus 5Q, that's the plus 25Q, plus 100. And I know I'm good. With your table partner, try number 11. So I got m plus 4 times m plus 4. Yes? The next one. This is not difference of squares, but there is something in common I can pull out. I can pull out an x. So x times x plus 25, and that is everything you can do. Try 15. Okay. This is difference of squares, right? So z plus 3, z minus 3. Are you guys starting to notice the difference of squares? Perfect square minus perfect square. Z squared minus 3z plus 3z, those two terms cancel out in the middle, minus 9. 1 and 42. Does 2 go into 42? 2 and 21. Does 3 work? 3 and 14. 4, no. 5, no. 6. Does 6 work? And 7 is the next number, so we know that that's every single factor, right? Because 7 is already there. So what multiplies to negative 42 and adds to positive 11? 6 and 7 is 13. 14 minus 3. So x minus 3, x plus 14. How about n squared minus 81? Who can do that really quick? Yes.
N plus 9 and minus 9.
Perfect. N plus 9 and minus 9. I think you guys are getting the hang of these, right? 1 and 30, 2 and 15, 3 and 10. Does 4 work? No? 5? 5 times 6. So we're done. Which of these add to positive 10? Positive 11? X plus 5 times x plus 6. And our last one, 1 and 7. 2 no, 3 no, 4 no, 5 no, 6 no, back to 7, so those are our only options. So if we had positive 7 and negative 1, that would give us our positive 6 and multiply to our negative 7. So x minus 1 times x plus 7. And that is how we factor without a leading coefficient, when our leading coefficient is 1. I hope you guys enjoyed today's lesson. Please like and subscribe and have a fabulous day. And don't forget to do your homework on page 385 and 386 in your workbook. Thank you so much and have a great day.